Now let us talk about GIS, and that too on the web. Web, we are talking about www, World Wide Web, or you can say internet. So GIS on the web. GIS stands for Geographic Information System. So what are the opportunities which are available in web-based mapping? Why web-based mapping is required, and what are the opportunities? What are the fields that can be used or that can be employed on web? So we have disaster relief and emergency management, because through internet any disaster is there or any emergency condition is there that can be monitored, and rescue work can be done. Also global and national geospatial information infrastructure like Digital Earth, NSDI and GSDI. Also crime management, because this goes pretty fast, and you need to take care, you need to respond very early in no time. And environmental monitoring also. There are many other fields. So how can we define this web mapping? Web servers and map where clients interact to this all web mapping. And first of all, we have discovery of access of and retrieval of views from multiple servers, then displaying of multiple layers of geographic data within a single web application. Then you can query and update. You can provide the visualization and decision support also. And finally, supporting of various formats like vector, matrix and other, like all these combined. This is an integrated view. Now you have internet here. There are so many things which are going on by actually using internet. You can show on a system all those things which are possible or via a GIS, that too on a web, that is on internet. And mapping on the web today is like this. This is one of the example, and this is another example. This is how you can see the map of an area. You can zoom in, zoom out, and this is an enviro mapper. You can see the discharge of water and hospitals, schools, etc. So how can I combine data from each of these sources to answer my question? Like I have a question which contains several parts. Okay, these three are working independently. Then we come to OpenGIS. Okay, this is how we because in earlier slide we just saw that coming on web and combining things and giving a combined solution is what the user is eyeing for, what it is requiring. So let us digress from the talk we just had and come to OpenGIS, and then we will go further and combine these two aspects. OpenGIS Consortium, it is a non-profit international voluntary consensus standards organization. It consists of industry, government and university members. Over 260 members worldwide, 30 countries in 5 continents, 91 European members, 19 countries, 35 Asia Pacific members like Japan and Republic of Korea, Australia, China and Thailand. So OGC, this OpenGIS Consortium, collaborates and works closely with ISO, W3C, OSCs and many others. And OGC has various membership level: associate, technical, principal and strategic. What are the specification for approved approved specification which we are using and we may use while dealing with web mapping or WebGIS? Okay, this is how I'm trying to amalgamate those things, that web mapping and this OGC approved specification. These are like simple feature access, OLE, SQL, CORBA, catalog and coordinate transformation, grid coverages, WCS, WFS, GML, SLD, style layer descriptor, WCS, OpenLS, and then the OGC web services, which is we are talking about, and web map client configuration. So starting with what is WebMap service. WebMap service is a mature, well-established specification. The version 1.0 was issued in 2004 and version 1.1 in 2001, this 12. So server and client support in many vendor products and freeware. You can find it everywhere, I guess. I must say that. And the scope is geographic data rendered as images. Now previously the data was humongous. You need to take from or you need to grab it from the satellite, and they are huge. There are so many aspects like format conversion, what is level 1, level 2 corrections, and all those things. Now you have images as maps, so not actual data values, but as these are images, like we have in ArcIMS image server. There are demo, you can click here and you can go there, but let's go to the others thing, which is WMS, that is WMS getCapabilties. This allows the server to advertise what it can do, like available layers, supported output projections, output formats, scale hints, extent of data, etc. And also this is in XML format. And then getMap, this allows, we are talking about WMS only right now. Then getMap allows the retrieval of a map from a web server. User supplies the bounding box, which area you want, the image size, the format, the error handling, etc. The server responds with an image, typically a web ready format like GIF, PNG or TIFF. Then get feature info allows the retrieval of simple feature attributes, and user supplies an XY coordinate pair and a layer of interest. Server responds with attribute information in HTML, GML or any arbitrary ASCII format. What are the limitations? All you get is a picture, not the data. The limited control over how the data is styled, particularly limiting with regard to the labeling. Support only a small portion of functionality, typically supported by a vendor. Then coming to WFS, that is Web Feature Service. The WFS 1.0 was approved in year 2002. ISO has requested it to be submitted. The scope is storage and retrieval of geographic vector feature data, that is point line polygon used in hydrography, transportation, government units, cadastral and geodetic control. And this is also similar to RGMS feature server. And what are the WFS interfaces? We have getCapabilties, describe feature type, get feature transaction, and log feature, get feature with log. Response to get feature request is formatted using GML, that is Geographic Markup language. What are the two classes of WFS? Basic WFS and transaction WFS. Basic WFS would implement the getCapabilties, describe feature type and get feature operation. This would be considered a read only, while in transaction WFS you can write also, you can change also. So a transaction web feature service would support all the operation of basic web feature service, and in addition it would implement a transaction operation. Okay, optionally a transaction WFS could implement the log feature operation. Then WFS has getCapabilties, describe feature type, get feature, and transaction WFS will transaction log feature and get feature with log. So what is describe feature type? It generates a schema definition for the requested features using the language specified in the capabilities document, that is XML schema, which is mandatory, others are optional. The XML schema document must be a valid GML application schema and defines the schema of the feature type listed in the request. So feature geometry must be expressed using GML geometry description, and SRS, that is special request reference system, must be consistent with the GML. When get feature, the get feature operation allows the retrieval of features from the web feature service, and the request contains queries which may unconstrained or constrained by a filter. Filter is described in describe, which is in the filter encoding specification, and the output format is GML, which is by default, but the specification allows other format also. What is GML? GML defines the data encoding in XML that allows the geographic data and its attributes to be moved between disparate system with all ease. Also GML separates content from presentation, which is the basic idea of XML also, because GML is XML based, so content is different from presentation. And one of the major breakthroughs with GML is that When used with XML tools, GML makes it possible to resolve many of the difficulties associated with incompatible data models. And it is not difficult to create profiles of GML, and this is what most developers will do. The Ordnance Factory of Great Britain and the US Census Bureau have committed to GML, and it is similar to ArcXML. This GML is an XML grammar written in XML schema for the modeling, transport and storage of geographic information. So GML provides a variety of objects for describing geography, including features, coordinate reference system, geometry, topology, time unit of measure and generalized values. So GML includes geometries and coordinate reference system, a temporal reference system and a unit of measure. So these are the three architecture cases: the picture cases, there is the graphic element and the data case. So architecture for different application: each map request sends new geometry, geometry remains relatively constant, and for the latter case means the coming case makes sense to cache and reuse coordinate information on the client such as much as possible. Because when you are working on web, you need everything to be fast. You cannot go back again and again to the server and expect or ask for the data. So for each application there is some right mix of the two approaches. From this geography markup to rendering, this is XML encoding of geographic features such as GML. Then this is VML, this is SVG, and this is how they are combined together. There are some web viewers like multi-view, multi-service, audio, Axio map. So thank you so much. Take care.